Hello, everybody. Welcome to the webinar. Thank you for joining on the call today. My name is Milind Kulkarni. I lead the product management team for the network functions platform at Array Networks. I'm joined by my colleague here, Kenny Kwan. He's a senior technical marketing engineer at Array. Before we go into the webinar itself, few logistic things to cover. We are running this through WebEx. There are two types of chat windows here. If you have any questions regarding the logistics and technical support, audio, anything like that, please use the chat window. There is also a Q&A window. If you have any questions, any feedback about the content of the webinar itself, please submit your questions, comments on the Q&A window. We have somebody monitoring, and Kenny is monitoring those windows separately. So that will help us get back to you quickly. And after the webinar, we will email the presentation out, a PDF copy of this presentation that for your reference and for those who have all registered. So without further ado, I will get started. Again, my name is Milind Kulkarni, and today's topics, we are going to do a broad spectrum on the state of IT infrastructure. First, we'll look at where the IT pillars are, then the key business drivers for any IT organization, and then specifically the challenges that are facing for network services virtualization. And then I will introduce the concept of Array's hyperconverged platform for networking and security. We'll talk about how Array solves the performance, cost, and complexity challenges in the world of networking specifically. And then we will show you 2 or 3 use cases, how our customers have used or have been using this hyperconverged product. And then we will take Q&A. But if you have questions as we go along, feel free to write your questions in the Q&A panel. We will try to address as we're going along as well. So if we look at the IT infrastructure, what we look at is any IT organization has 4 pillars. There is software, there is servers or compute, then 3rd pillar is storage, and 4th pillar is networking. And the people who actually make it happen are server developers, server admins, storage admins, and network admins. If you look at their roles in last 20 years, you can see that the app developers' world has changed. Their roles have evolved. They have gone from monolithic client-server application to a very microservices-based cloud-native app development of late. That's where they are all heading towards. For server admins, they managed standalone servers about 15, 20 years ago, and each server admin typically managed, give and take, 20 or so servers, 20 to 50 servers. Now with virtual machines and VMware, the server admin now is able to manage a lot more virtual machines and a lot more virtual servers with orchestration, and that number has gone up from 50 standalone servers to anywhere in hundreds of virtual machines. The storage admin, their role has changed too quite a bit, from block and file storage equipment in racks to virtualized storage with software-defined storage as well as hyperconverged infrastructure. The last pillar of the IT, which is the network admins, they have been dealing with static monolithic devices, and unfortunately they are still having to do that, although there are rays of hope quite a bit, but their world predominantly still is confined to static monolithic devices. While those 4 pillars of IT are changing, the higher level business drivers for all your businesses is completely different. Your companies are trying to do these 5 things. These are 5 business drivers for your organizations. Number 1 is all of you want or are looking for business agility. You want to align your networking with the DevOps culture that the application teams have. You want to be able to react quickly to internal customers as well as external customers so that your infrastructure is agile. The second business driver is you want to adapt quickly to changing threats. There have been a plethora of security breaches and security attacks, one as recent as 2 weeks ago when Cisco had to announce a vulnerability, and that's just our state of the technology today. So all of you are looking for ways to quickly adapt to threats. The third is consolidation of your infrastructure. You have lots of racks and racks of equipment from 20 years ago to the most recent one, and you want to consolidate that because that helps you reduce costs from capital expenditure as well as operating expenses. And number 4 is hybrid cloud adoption. Is as you have on-premise infrastructure, you're also looking to augment that with something that's public cloud as well. So these 5 are key business drivers, and I'm going to focus specifically on the networking piece. So the networking team, when they look at these business drivers, one of the solutions that they're looking for is how do I make use of networking and security virtual appliances, because that's what is going to help in addressing these 5 things. The networking and security virtual appliances will help in addressing the business drivers. But before I do that, I want to really quickly give you an overview of what does the disaggregation of networking services look like. This may not be a new concept to many of you. You may have heard this already. We call this as network functions virtualization. But some of you who may be new to this term, I will take a minute to explain what this really is. On the left side of this picture, we have used, or many of you used, a purpose-built, dedicated networking device. This device has its custom hardware, its custom silicon, with custom operating system and running custom protocol stack or feature functionality. So that comes from one single vendor. That's what we have dealt with for a long time. The right side of this picture talks about the disaggregation of the services where every layer is split differently, and that's why the use of different color, where the hardware is based off of a standard x86-based architecture, a standard Intel architecture. On that hardware, you have a hypervisor from many of the well-known vendors today. And on top of hypervisor, you have virtual appliances. They all can come from different vendors. So certainly, from going from left to right, we have the world where the networking device is disaggregated and the functionality and the components come from different vendors. And this provides tremendous advantages, and it goes exactly in the need of fixing the business challenges that we looked at in the past. While virtual appliances is a great idea, there is a trade-off that every network organization has to deal with. The positive side is the network virtual appliances, they provide flexibility and efficiency because that's what a standard portable software-based platform does. But on the negative side, there is a performance penalty to be had because it may not be able to match the performance and scale of a dedicated networking appliance that is built on a custom silicon. While it can also add cost and complexity because to achieve same amount of performance, you may have to throw more hardware at it or more server at it. So there is a trade-off that's going on. So the pain points for network services virtualizations are threefold. Number one pain point is performance. A general purpose Intel-based or x86-based architecture coupled with hypervisor overhead and virtual machine contention, they severely restrict performance. The second aspect of that is any rogue appliance, any rogue virtual appliance can starve other functions that are running on the platform. The second pain point is complexity, because network services virtualization is extremely complex to configure, fine-tune, and debug. It's not easy to do unless you're really familiar with all those terminologies, because it requires skilled talent that understands hardware architecture, software, and driver optimization. And third pain point is cost, is where more servers are required for achieving the same level of hardware performance. And not only that, it requires time and training for a network administrator to bring the team up to the latest technology. So all of that includes cost. So let me deal each of these challenges a little bit more in detail. Performance challenges. On the left-hand side, what we're showing here is a typical x86-based architecture that is used in a networking device. And I'm talking about only the left side of this picture here. In the x86-based architecture, there are NICs or network interface cards that connect to external world or external ports, and those NICs pass the traffic on through hypervisor, through a virtual switch, through virtual NICs, and through virtual machines or virtual appliances. In this scenario, there are performance constraints and resource contention because every lane or every traffic lane is shared among different virtual appliances or virtual machines. So recently there was NFV World Congress, and an architect from Orange essentially said, hey, a generic server is not enough. The power consumption is too high, and the performance is not great. We need a server that has a combination of FPGAs. And the same conclusion came out of SDX Central report, where they said, the conclusion was a standard server is not enough. I need something more to beef up my performance on a standard server. So that's about the performance challenge. Second is complexity challenge. I'm talking about the left side of the picture here, is if you are trying to deploy virtual appliances or virtual versions of any networking software on x86-based hardware, it's extremely difficult to do, because you have to know, as a network administrator, the virtualization in-outs. You have to understand the driver considerations. You have to understand how to configure SRIOV. You have to understand how do you bypass vSwitch. All of those things are very complex. So when the survey was conducted on the right side of this picture, you can see the number one concern from many of these organizations is 64% of them said, we lack training or in-house talent to actually optimize any of the x86-based servers. We just don't understand. We just don't have the right skill set. So what Array did, starting about 2 or 3 years ago, was we decided to solve the performance, cost, and complexity challenges for businesses so that they can move towards virtualized networking, security, and application delivery. That's what we decided to do. As a result of that, we built a hyperconverged platform for networking and security. This platform is called Array AVX. And the platform is essentially a hybrid of two important concepts. On the left side, the platform leverages x86-based architecture, so it becomes a virtualized server. On the right side, it is designed as a dedicated network appliance, and therefore it provides guaranteed performance. So it combines the best of both worlds. It gives the agility of a virtualized server. It lowers the CapEx and OpEx. At the same time, it makes configuration quite simple. It makes deployment of networking applications quite simple. And while doing that, it guarantees performance. So this is for the first time. So essentially, it improves the gaps that were there in earlier solutions. And therefore, it becomes a hyperconverged platform for networking and security. So before I go into the specifics of the platform, I want to give an analogy. I want to give you a story that you may have experienced yourself. Imagine taking a road trip, a family road trip to Disneyland maybe 10, 15 years ago. What did we start with? In the past, we looked at a packaging list, and Disney publishes that very well. It tells you what to pack when you're going on a family road trip or a vacation to Disneyland. We went to AAA. We got a bunch of paper maps. Then we looked at our local TV channel or newspaper for weather forecast. Then we took our camera to take pictures because we are going on a family vacation. If we have kids with us traveling, then we took some games, movies, music to keep the kids occupied, and hopefully they remain entertained. We also carried flashlight just in case of emergency if something were to go wrong. We had our phone diary contact list in case we need to contact somebody. We actually carried a paper version of the phone diary. And then since we are going on a travel, we'd obviously not leave home without credit cards and watch and things like that. This is what we did 10 to 15 years ago. What do we do now? We just carry a smartphone. The smartphone has all same capabilities, but not only that, they're even better. For example, the road maps are not only road map, but they'll give you satellite image. And along with that, you can also have real-time traffic with it. The weather forecast is not static. It is actually dynamic, and it is targeted based on where you are at that point. Your camera is not just the phone. It is a lot better resolution, and it's connected to internet, so you can instantly share the pictures. You get the idea. The smartphones of today are agile, simple, compact, future-proof and consolidated. They consolidate lots of things into one single thing. And future-proof because you can download an app that you are missing. So we have made this choice in our personal lives. But we need to make the same choice in our professional lives, in networking layer specifically. So in the past, in the networking world, many of our racks look like standalone networking devices. Maybe you have a DDoS and DPI box from one vendor. Maybe you have a load balancer from another vendor. Maybe you have a firewall, very old firewall from another vendor. Maybe there's another VPN, DNS, DHCP. We have seen this. This happens to be a network services layer that we have seen. That's what we did in the past, but now with Array AVX platform, or the hyperconverged platform for networking security, we can hyperconverge networking and security functions on this platform. It's exactly similar to the concept like a smartphone, where this platform now is agile because you can download anything you want, any networking function you want on this platform, and run it. It's simple. It's compact because you're going to save a bunch of rack space. It's future-proof because if there is no functionality available, you can download from vendor of your choice. And it consolidates lots of networking functions on one single platform without compromising on the performance. That has been one of the challenges in the past. And therefore, you can run networking functions from any of these vendors, and it's just a sample representation. There could be any other from F5 or Cisco or Infoblox or whoever. Any networking function that runs on KVM will run on this platform, and we have tested many of those. We have performance proof points on this platform. So in a nutshell, Array is doing for networking and security exactly what Nutanix did for compute and storage. Remember, an data center, an IT, has 4 pillars: compute, storage, networking, and security. So Nutanix hyperconverged compute and storage. Array AVX hyperconverges networking and security. Same concept. So if you've used Nutanix, if you're thinking about Nutanix, then this will complement your Nutanix approach. These are very complementary solutions. On the right side of this picture, what I'm showing is a rack full of networking, standalone networking equipment. With array AVX, you can just consolidate them into fewer of these platforms, and therefore you can save on power, space, cooling, cabling, and all sorts of costs. And while doing that, you are able to align your spend as pay as you go. We're going a little bit more into details now. On the bottom of this picture is an actual photograph of arrays, one platform called AVX 10650. It's one of the higher end platforms, and I will go about the platforms, actual platforms later in the presentation. But on this platform, it is capable of running 3 types of applications, or 3 classes of applications. Number 1, starting from the left, is array functions. Array makes virtual appliances, specifically virtual application delivery controller, or virtual SSL VPN, or virtual WAN optimization controller. So those functions can come from array, and you can choose to run those virtual functions on this array platform. But if you don't want array, that's perfectly fine. You can run the second class of application, which are third-party applications, and we have tested many of those. That could be, and these are just a sample representation. You can run applications from WAN optimization from Silver Peak, or next-gen firewall from Fortinet, or ADC from F5, or something from Citrix, and so on. We have tested that. We have tested Cisco functions and so on. Many of our customers continue to use that. So that's the third-party applications. Many networking organizations are also considering open source functions as they consider their network. And therefore, you can run open source networking functions on this box. These include things like HA proxy or Nginx or something like that you can run on this box. You can also run an Ubuntu or CentOS Linux versions on this platform, and therefore it becomes an interesting combination of not only a networking device, but you can also avail some utilities that you might have already been using. And one example being one of our customers in Asia Pacific is using networking function along with billing that runs as a Linux application. So the application capabilities that you can run on this platform are really limitless, and this opens up a whole new world of what you could do and consolidate your networking services layer. So how do we achieve hardware-like performance for the virtual appliances? And the secret sauce includes these 6 factors. Essentially, we have a technology called SpeedCore that uses multi-core packet processing engines that uses the latest generation of Intel chipsets. So that gives you the portability. At the same time, it also gives you a high packet processing capability. The second is it has hardware-accelerated SSL, where we use crypto chips to accelerate crypto-specific functions. They're also enabled with SRIOV configuration or single root IO virtualization configurations, where that guarantee fast lanes for traffic in and out. Now, these lanes are also connected with 10 gig and 40 gig interfaces, so that gives you ability to send packets in and out of this platform. While doing that, the internal resources of CPU cores, SSL cores, RAM, and IO is reserved for particular virtual appliance, and that's pre-configured. So one appliance will not interfere with the other. And these are done with a hypervisor that we have specially tuned for this hardware. And all the underlying complicated tasks are automated for you, so you don't have to be an expert in things like SRIOV or DPDK, NUMA boundaries, and CPU pinning, drivers, port mapping. All of that is done for you. So it's abstracted for you, and you can just do it using a simple click. And that guarantees you performance. So let me give you an example of what is happening and how does this typically work. So imagine on a virtualized platform like this, and you say, I want to run a large instance of virtual ADC or virtual application delivery controller. As soon as you install that, as soon as you create a virtual appliance that is a large instance, you can see that the 8 CPU cores get allocated, 4 SSL cores get allocated, 4 interfaces are allocated, and some memory gets allocated. Now, if I say I want a medium instance of VPN, only half the resources will be allocated. If now I want to install a medium instance of a virtual web application firewall, again, half the resources compared to the large instances are allocated. And if I want a large instance of next-gen firewall, all the resources are allocated. So this is what is happening. Now, if we go a little bit under the hood and see what is really going on, I want to show this animation to make a point how the automation is done for you and how you can deploy this in minutes and why it takes minutes and not weeks or months. So what you see here is the orange layer, which is the array operating system. That's the secret sauce. On top of that is a KVM hypervisor that's tuned essentially for networking performance. On the bottom, you have the network interface card and SSL cores. On the right side here, we have CPU cores, and to the rightmost, we have a representation of RAM. If we say I want to install a medium instance of a SSL VPN, the instance is very similar to what you would use in Amazon Web Services or AWS or Google Cloud. You say I want an instance of certain size, very similar concept. You say I want to install a medium instance of SSL VPN. Now look what happens. The array operating system is allocating the cores automatically. It allocates memory. It creates the SRIOV lanes, and therefore now this instance has everything automated, and the instance is ready for running the application workload. Same thing happens if I install 2 other small instances. The array operating system again automates things behind the scenes, creates the CPU pinning, creates the NUMA boundary setting. It maps the virtual ports to physical ports to virtual ports. It creates SRIOV configuration. And now you have dedicated lanes, and that's how we guarantee hard performance on this hyperconverged platform. Now, if you're trying to do this by yourself, and many of you may have already done this, optimize the same thing, what I just showed you, you could do that on a server, on a generic server, which is not going to give you high performance, but you can always try, and that's what some organizations have tried. And what they realize is when you're trying to optimize a generic server for virtual machine performance, you have to do at least these 9 major steps. Step number 1 is you have to select a server that supports SRIOV, that supports port mapping, that has the NICs that are capable of supporting DPDK. You have to understand the CPU pinning boundaries and NUMA boundaries. So that's going to take you, let's say, a day or 2. You have to understand your company's virtualization strategy and select the appropriate hypervisor. Maybe that's a shorter task. Maybe you know that already. That takes less than an hour. Then the difficult work starts. Now you have to configure SRIOV and create a set of virtual functions, and that involves a whole set of subtasks. If you're not familiar with SRIOV, then you have to research and learn about that. Then you have to make sure that your Ethernet controller, hypervisor, and guest operating systems are supported for this specific version. Then you have to go into Intel-specific things such as just to make sure that Intel VTD is enabled in the BIOS. Then you have to copy some configuration files. And as you can see, this can take pretty long time. It can easily take from anywhere from 1 to 3 weeks, depending on your expertise. And you have to do the same thing for DPDK. Now you have to do the same thing for CPU pinning. And all of that, once you do this, it's going to take you anywhere from 3 to 7 weeks. this is what happens, and that's why people have been slow in adopting a generic server for their virtual appliance, networking appliance. And we had realized that as a problem a long time ago, and that's what we automated. So on the right side of this picture, what you'll see is the Array AVX platform, which is the hyperconverged platform. We have simplified the whole thing. All you have to do is go through 4 steps. You have to say, choose which service to virtualize. Again, the 4 steps that you take here are very similar to what you would do if you want to run a spin-up a networking services in AWS, for example. You just choose a service to virtualize. You say, I want to virtualize web application firewall. Then you import that virtual appliance. That's going to take you maybe 10 to 15 minutes because you're downloading that appliance image onto this platform, and maybe depending on your connection, it may take up to 15 minutes. The third step is you create services virtual appliance, and in that, just like you would do that on AWS, you have to enter the name for this virtual appliance. You have to tell what size you want. Do you want a small instance, you want a medium instance, you want a large instance, and so on. Then you enter a domain, what domain this appliance is running, and then you tell the image name itself. That takes 2 minutes. And then you click start, and your virtual appliance is up and running in under 20 minutes. Now compare and contrast that with what we looked on the left side, right? So that's a significant amount of saving done for you. All of that you can do using a graphical user interface, a CLI, or a REST API. You can quickly provision and interconnect services, and what you're seeing is just one initial screenshot of the AVX management GUI, essentially showing that it is running a bunch of virtual appliances there. In subsequent webinars, we will actually show you how to do this live. So Kenny will do this as we go along in the future webinars of how to do this and how simple this is. So I talked about the platform, the hyperconverged platform for networking security. But I want to leave you with the impression that where these are the ideal places you would use this platform and the places where you would not use this platform. So going from left to right, what I'm showing is an enterprise branch connecting to a data center on the right, and it's connected through some sort of a telco infrastructure, either a colo or a POP or a central office and hub and spoke location and so on. Each of these locations have a set of networking functions that exist today. So the letters that are in green color that are suitable for deploying this hyperconverged platform. The networking functions that are in red color are not suitable. I would not recommend this at this time because it makes no sense. For example, a PE router or MPLS router or a CE router or core switching and core routing is not the right application to run on a hyperconverged platform for networking security. But your data center services layer is an ideal place to deploy this hyperconverged platform where you can hyperconverge load balancing, firewall, IDS, IPS, monitoring, packet brokers, management, DNS, DHCP, backups, all of these functions, you can consolidate them on this hyperconverged platform. Let me give you a specific example, 2 specific examples, how our customers have used it. This is use case number 1. Our customers, they use this platform essentially as a multi-tenant platform for application delivery. Their e-commerce team wanted 2 large instances of load balancers for scaling their premium application. Their sales organization had CRM application, and the load on that system wasn't as high, so they installed a medium instance of a load balancer or a virtual application delivery controller on this platform. They had another enterprise ERP application that also wasn't needing as high performance and a high scale, so they deployed a medium instance. And then they had IT department where they had some old homegrown apps that they wanted to just continue for the sake of continuity. So they were able to allocate small instances of virtual appliances on this platform. So what's shown at the bottom is essentially the platform that's providing guaranteed performance and the agility at the same time. So this is use case number one, where the customer of the platform used multiple virtual appliances for servicing in-house needs. Use case number two is another customer. They had consolidated, they had equipment from these two vendors in the past, F5 and Palo Alto respectively. They had 6 next-gen firewalls and 2 load balancers that had come, that had been due for renewal, and they realized those applications are not getting used as much. So they essentially decided to virtualize all of them on this one single platform. And in doing so, they were able to just transfer the same functionality and the licenses of their existing vendors onto this platform. In doing so, they saved almost 8-to-1 reduction in space, power, and cooling. And they didn't have to go on-site for deploying this hardware-like services because now they were able to deploy them remotely. This is use case number two. There are many other use cases that are possible. Feel free to contact us and we'll walk you through even more interesting use cases. But I want to show just the basic and simple ones where we see. Obviously, the third use case that I don't show here is a test and development, something that you want to test in your lab. You can quickly try your applications in development. So why have customers been choosing this hyperconverged platform? For these 5 reasons. Number one is this platform provides the agility of virtualization. Now you are able to quickly provision, install, resize your application, networking application as and when needed at the speed of software. Number two, in doing that, the platform, they are still retaining hardware like SLAs because there are resource guarantees. It will provide guaranteed performance and scale. So you are not compromising on performance and scale because of agility of virtualization. Third is because the deployment is simple now, it's single click, essentially a few clicks, all of things are done for you in the background and automated for you. It's quite simple to deploy. Number 4 is it is because it's a vendor neutral platform. Now you don't have to depend on vendor one or one vendor to provide their own hardware. In this vendor neutral platform, you can run anybody's virtual appliance as long as it runs on KVM hypervisor. And last but not the least, this platform therefore provides very high efficiency and very high value to any networking services layer because it's minimizing the power, space, cooling, and the hardware costs. So before I go into the next topic, I want to just show you a high-level view of platforms and performance. There are 3 form factors of this hyperconverged platform. There's AVX 3600, which is what we call as a 1 RU platform. AVX 7600, which is a 2 RU platform, and AVX 10650 is also a 2 RU platform. And they increase in their performance and scale from left to right. For example, the AVX 3600 can run 1 large instance or up to 8 micro instances, or what we call entry instances, or some combination of these two. The lowest end platform is capable of providing 40 gigs of SSL throughput, or also max layer 4 throughput, and up to 600,000 layer 4 connections per second. And if you go to the rightmost of this chart, which is AVX 10650, this platform is 4 times as powerful as the lowest end platform. Therefore, everything is scaled up by 4 times. In case you haven't been completely familiar with Array, I just want to give a high-level view of what Array Networks is. So Array is a company headquartered here in Milpitas, California, which is Silicon Valley. There are 30-plus technology patterns. When we made this slide, there are 3 main product lines that we made. Number 1 is the network functions platform, which is the hyperconverged platform for networking and security. That's what I just talked about. And then we also make application delivery controllers, secure access gateways, and so on. Array has customers in enterprise, service provider, and public sector. The logos are on the right. You can see there are 5,000 customers worldwide. The customer logos that you see on the right side of this image are publicly referenceable, and therefore they are on our website. There are case studies on how and what we have done. And last but not the least, because Array is a global company, we are able to provide 24/7 support. With that, I want to thank you for your time and open up for any questions that may have come up. Okay, I see one question, which is, how does this platform guarantee hardware performance? So I'm going to request Kenny, do you want to take that question?
Sure. Basically, as Milind indicated earlier in the presentation, we are integrating the SRIOV technology, and that involves using a dedicated or specialized network technology from Intel. And basically how that works is one physical traffic port on the AVX can be virtualized as 8 SRIOV virtual ports. And so what that really means is that you can provide each virtual network function its own dedicated network traffic lane. So you're not sharing the same network traffic lanes. And along with that, also because we're also with the Array virtualization technology, we're actually reserving dedicated resources for each virtual network function.
Good, thank you. Second question, how do you manage this platform? And let me address, and I'll address and I'll hand it off to Kenny. This platform is capable of supporting graphical user interface. You can manage this platform using graphical user interface, or you can manage it using a CLI, or you can manage it using REST API. And last but not the least, we have something in the realm of OpenStack. And can you talk about OpenStack and how this can be managed on OpenStack?
Yeah, with OpenStack is it's going to say it's a open source technology that allows you to run a virtualized environment, and it's quite prevalent, in the industry because it's open source and it's available for everyone to use, not proprietary. What we're planning to do with AVX is we're planning to integrate that. And if you're familiar with OpenStack, there's a concept of compute nodes where you're actually running virtual appliance instances. And in our case, AVX will be configured as a compute node. And with that in mind, you'll be able to use the AVX as a compute node, as a virtualized host. So the sizing of the virtual appliances will also apply. There will be a new set of sizings for AVX models.
Okay, thank you. And third question I see here is the licensing. How does the licensing of virtual appliances work? And the answer to that is most of our customers have told us that they have existing relationship with their networking vendors that of their choice. So they want to keep that relationship. And we have honored that. And as a result, you can continue to work with your existing networking vendor, buy the virtual appliances using your existing channel partners, your existing relationships, and download those applications on this platform and they will work as they are. So that is the licensing. So we do not change any of that. Your existing processes do not change. But while consolidating, you're still going to get all the benefits. Any other questions? Okay, so there are no other questions. Obviously, Kenny and I just gave you a quick overview of the system. For more information, please reach out back to us. We will send you the presentations. Please let us know, and we will be happy to do a very deep dive and a demo of this product as well. So we'll be happy to do that at a time of your choosing. And once again, thank you for taking time off your busy schedules. Appreciate being on the call, and we're wrapping up. Have a great day.